So here we're going to demonstrate how to apply linear regression. It says in a nutshell, linear regression is concerned with modeling a linear equation that can be used to predict or forecast future values. This course is concerned primarily with two methods in which this can be done: least squares and geometrically via the scatter plot. So in least squares now, the equation of a straight line has a standard form y is equal to mx plus c, where x and y are the related variables. In our case, this is score and hours of study and score. X is the independent variable, y is the dependent variable. So hours independent, score dependent, score depends on the hours, m is the gradient and c is the y-intercept. Here is the steps to obtain the linear equation via least squares. First, you calculate the gradient using the formula m is equal to n times the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x all squared. And as you can see now, interestingly, please note that all the elements of this formula can be encountered in the product moment formula, namely sections 1, 2, 3, and 4. So numbers 1, 2, 3, and 4, we have already calculated these numbers when we did Pearson's product moment. So therefore now, we can recall that R is equal to A over the square root of BC. The formula for the gradient M can now be simplified to basically A over B. Okay, because as you can see, 1 minus 2, the first minus the second is capital A. The third minus the fourth is capital B. So it's just A over B. The gradient is simplified to A over B. And C now, here's the formula to calculate C, which is the y-intercept. The sum of y, which you calculated already, minus m, which you just calculate, times the sum of x, which we calculated already, over 7. And then you just write it, place these values, m and c, in their respective position in the equation y is equal to mx plus c. So basically, as you can see, to find m, we just have to do a divided by b. So basically, m, which is the gradient, is equal to a over b. Here is a in D10 divided by b, which is in D11. And that will give us a value of our gradient m. We can reduce this to 2 decimal places, 0.92. And c now, which is the y-intercept, is equal to, open bracket, the sum of y. Here is the sum of y, 522. Here it is, the sum of y, minus m times the sum of x. Here is m times the sum of x. The sum of x is in A9, close bracket, divided by n is 7, and this gives us an estimate of the y-intercept. We can reduce this to 2 decimal places, and basically we can write out our equation, y is equal to mx plus c. So here we have written the equation, y is equal to mx, 0.92x plus c plus 47.31. And we can modify this formula because y is score and x is hours. So we can actually use those words to particularize this formula because y and x are generalized letters. But to be specific, we're going to use score and hours. Now, if we go to example 8.1, we can see that their x variable was units and the y variable was cost. They use U for units and C for cost. And when they found the equation y is equal to mx plus c, here they calculated m and they calculated c. M is a over b, c is the sum of y minus m times the sum of y, sum of x, I suppose the sum of x, that's a typo, over n. They got 2 and 5, so they have y is equal to 2x plus 5. And they replace y with c for cost and u for units, because units was the independent and cost was the dependent. Now, in our case now, we have hours and score. So we can use H for hours, and we can use S for score. So we can particularize this equation and write S is equal to 0.92 times H plus 47.31. So that's the linear model. That's the linear equation that was derived from this data set using least squares. So you can type in Google linear regression calculator, and we are going to prove our equation using that online calculator. So our X values, let's copy it and paste it. There are numerous calculators there. So this one, I think, is social sciences. You can use this one, or you can use any other one that are available to prove your calculation. So these are our X values, these are our Y values. And we can calculate the linear regression equation. Here it is. Y is equal to 0.92. 0.917 is 0.92 plus 47x, plus 47.31. And here we have proven our calculator. And also, you can see, it also gives us a scatter plot. So we can also copy this as proof of what we have done was correct. So you can use an online calculator to prove your answer, linear regression.